Thank you, Matteo, and welcome everybody to this talk this morning. Hope you had a great first day at the conference yesterday and some nice coffee this morning. So today I'm going to talk to you about Red Wizard. It's a new open source tool that we from Secura are releasing today. And that's something that you can take with you to your own company, take some inspiration from it, or make your life a little bit easier. So the goal for the talk today is really simple. We're publishing the tool today, and I'm going to show you how it works, why it works, and why you might want to use it or use it as an inspiration for your own stuff that you are building internally. And during the presentation, I will show you how to build a moderately complex red teaming infrastructure in just a few minutes that you can then deploy on your own servers, and it makes infrastructure for red teaming quite a bit of a breeze. So for the talk today, we're going to start out with a small introduction on red teaming in general, because maybe not everybody is aware on how it works. Next off, I'm going to show you why infrastructure is important for red teaming in general. And then we go into a more deep dive in Red Wizard, how it works, why it works, and also I'm going to show you a demo on how you can use it yourself. So first off, who am I? My name is Ben Brucker. I've been with Secura for more than 8 years now. Trained penetration tester and social engineer. And since I've started red teaming, I felt a lot of pain deploying infrastructures, using infrastructures, and I wanted to make it a bit easier. And that's why I started developing this internally at Secura. So first of all, a small introduction about red teaming. What is red teaming? So in general, for red teaming, you perform a realistic cyber attack against one of your clients, hopefully. And there you test the detection, mitigation, and response capabilities of the defenders. And red teaming is quite an in-depth process where you touch upon the process, people, and technology side of the defenders of your target companies. And pretty much everything is in scope by default. So physical access to buildings, social engineering via phishing, phone-based phishing, social media, leaving rogue devices in your target network, external, internal network compromises, all with the goal of simulating some high-impact event. For example, can you turn off the power in a part of the Netherlands in a certain time period? Or can you steal all the important data of patients of a hospital? Anything that would be really critical for an organization that they don't want to happen. During a red team, you test if you can make it happen from the perspective of an attacker in order to help them to better defend themselves. And red teaming can be quite unforgiving. Usually you start an attack, and once you're detected, it's really hard to come back from that and make sure the rest of the attack will be as realistic as possible, because after detection, the blue team might react in a different way than before you were detected. So making sure that you know what you're doing and making sure that you have the right tools is really important within red teaming. And yeah, in order to perform all the attacks that you have, all the phishing attacks, the malware attacks, and so on, you do need a little bit of infrastructure. And some of the common components that you see in every red team are stuff like phishing, malware command and control, some type of callback catchers, man and middle phishing, OSINT machines, and some backend for some hardware implants that you might leave behind in the target company. And the infrastructure that you have is quite important on how you build it and how you protect yourself. Because compared to a normal pen test or a normal security test, you're not doing this in isolation. You're actively working against the blue team that might want to detect you, that might want to figure out who is behind the attack. And from the red team, it's your job to make sure that you aren't detected and that people cannot trace it down to you as a security company, for example, in order to keep up with the realism of a realistic cyber attack that you're performing against the target company. So the most basic setup that you could have for an infrastructure would be that you have your command and control server and you perform an attack against your target directly. However, the blue team might be onto you. They detect, hey, you send out a phishing from the server, and pretty much then it's over because they detect, hey, this is your command and control server. It might be linked to you and the game is up. So that would be less than ideal and nobody's using it. So pretty much in every red teaming infrastructure that you find anywhere on the internet, they use some derivative of this setup. So you have a command and control server. That's your private server. That's where you do all your work from. You have a relay server. That's burnable infrastructure on the internet. That shouldn't be traceable back to you. and you have your target. So you perform your attack towards the target via the relay server. And if anybody investigates, they shouldn't be able to find that is you who's behind it. And if you detect, hey, the blue team is onto us, they're doing some additional investigation, you just burn your relay server, you take it offline, and you just deploy a new relay server, and you can use the same command and control server to perform the attacks against your target. This is much better than the first one for obvious reasons. And during a red teaming assessment, you might have to do this a lot. One, it might be that you have a lot of assessments going on. It might be that you need to have a lot of infrastructures because every client should have their own infrastructure. And it might be that you have really good blue teams that are really onto you and they detect most of the attacks that you do. And you might have to spin up new infrastructure at a very short notice. And that's where our tool comes in, Red Wizard, that we have been creating. This tool will help you create your infrastructure and make it much easier to deploy all the stuff that you need in order to attack your clients. So first off, what is Red Wizard? Red Wizard is a server provisioning software that will install all the parts of the infrastructure that you need. It will put in all the connections between the servers that you need. It will pre-configure sending profiles, for example, your phishing campaigns. It will pre-configure listeners for your Cobalt Strike payloads, etc. So it will automate a lot of the stuff that you need in order to start hacking your target. What it is not a server deployment software. So we have a few requirements on the software that I will get into later. So you still need to provide your own servers, for example, Ubuntu 20.04 servers, and you can really easily do that with, for example, Terraform in your own environment, but that's not something that we are currently releasing together with this. So why did we make it? First off, as I told you, doing the stuff manually for a few years is really, really painful, and you don't want to do it, especially the more complex the stuff is that you do, the more complex the infrastructure is getting. Also, there are red teaming infrastructures out on the internet, quite a few actually. However, they are either quite limited in our experience, or they are pretty hard to use and use a lot of black box stuff, and it's hard to explain how they exactly work. So we wanted to get away from that. So our infrastructure is built in such a way that must be really easily explained to new team members that you might have. Also, the person who deploys your infrastructure is usually not the operator. I mean, it can be, but it doesn't necessarily have to be. So the operator needs to be able to easily make use of the infrastructure that you're deploying without knowing all the details about how it specifically works. And any information sharing, like I want to give, if I deploy our infrastructure and I give it to our red teaming operators, I just want to give them 2 or 3 files that I don't have to put any work in and tell them, here, this is what you can use, go have fun. So the less time we spend on this, on the information sharing internally and on the deployment, the more time you have to actually hack your customers, which is much more fun. So it's definitely not unique because there's other infrastructures out there that does fancier stuff than we do, to be fair. But the user friendliness in both the deployment and the use of it, that is different from what you can find out there so far. Also, we have been using it internally for about 2 years now, and it is really robust and solid, and we are really happy with it internally for months-long operations that we have been going on. There are a few of design principles that we have been working on. Keep that in mind. It's not the most fancy Kubernetes cluster, etc. All is really simple, but that's by design because we want to make it easy to share with other people how it works. We want to use basic components as much as possible. OPSEC is really important because, you don't want the blue team to track down you as a red team. So operational security, make sure that nothing can get into the server, that everything is deployed as secure as possible. Really important. It must be robust. If your server crashes halfway through an operation, you're not going to have a good time. And we are not making use of black boxes, so Docker containers that you download from the internet, etc., in order to make sure that you know exactly what's going on. And if you need something else for your operation, you can really easily patch it in yourself. Everything must be self-documenting, so when I deploy an infrastructure, all the documentation must be there right at the fingertips for the operator who's going to use it. and as much pre-configured as possible. So you should have sending profiles for your phishing campaigns, so you don't have to configure it later. Listeners for Cobalt Strike, for DNS, for HTTPS, for example, just to make it easy. And it should log everything somebody is doing, because what happens if somebody makes a mistake and something goes down at the client, or you made a mistake and forgot to write something down in your timeline. So you should find all the actions that you have been doing in all the logs that are on the system. So the maturity, we have been using it internally for more than 2 years now. It's been working really well, so I'm happy with the maturity. However, the public release, this is now the first version of the software that we release publicly. It doesn't have some of the features that we have internally, so there might be some bugs in there, but we're going to work on them. If we any bugs are reported, we're actually actively going to fix them. So the technology, mainly based on Ansible for the server provisioning, Docker in order to have Docker containers on our C2 machines that do the different tasks that we have, and Python that stitches it all together, does all the deployment scripts for us and creates our inventory, etc. And I'm going to demo you later how it exactly works. Basically, if you want to use Red Wizards, there are 4 steps that you need to do in order to deploy your infrastructure. So first, you need to create a basic configuration for your team, for your company, for maybe some configuration for your teams, and that's the configuration that you use as basis for all the deployments that you do afterwards. Then as the second step, you're going to create a configuration for your new red teaming campaign that you're actually deploying. And then after you have your basic configuration, you're going to create an inventory of all the systems that you want to have deployed. And then you deploy it, and afterwards it should all work out of the box for you without any post-configuration that you need on the infrastructure itself. Again, in order to keep it as simple as possible, we made the requirements as simple as possible. So the deployment system, that can be your laptop, it can be a VM, it can be a specific deployment server that you have internally, just should run Ubuntu 22.04, and everything should work. 20.04 also works. The target systems, the backend servers, the relays that you're going to deploy to, use Ubuntu 20.04. 22.04 will be supported in the very near future, but there were some bugs that we still need to fix. And you need to have one deployment user that's available on all the machines for Ansible in order to connect to the systems. Need to be able to connect to the system via SSH and need to have a sudo password set. And this is all you need. If you have those servers ready, you can easily do it with Terraform or any other software to deploy some servers. Then you're good to go for Red Wizard. So before I show you the demo, so you know what you're actually looking at, I'm going to show you how the basic building blocks of Red Wizard actually work. So you start off with a command and control server. And on that you deploy some type of infra component. For example, a GoFish Docker, Cobalt Strike Docker, anything else that you use to actually do your work in. Then you have your relay, and Red Wizard makes sure that it will deploy it in such a way that there's an open VPN tunnel from the Docker to the relay. And it's configured in such a way that the target, who, for example, receives a phishing link, will be relayed through the relay, through the open VPN tunnel to your infrastructure component. But you don't want to have everybody to reach your internal components, and that's why the rest of the internet who doesn't have the right string, for example, in the URL, they will just end up at a relay or get redirected to anywhere else on the internet. And that should make it much easier to keep your infrastructure secret. For example, there are tools out there that scan the entire internet for Cobalt Strike instances. So you don't want your command and control infrastructure to turn up in those scans. So that's why only very specific URLs get forwarded to your Cobalt Strike instance on the backend. The same for phishing or any other components that you have. And you can deploy multiple components on the C2. So for example, you have phishing campaign 1 that goes via relay 1, a second fish that goes via a second relay. You have a Cobalt Strike that goes to a third relay. That would be the most easy configuration. But you can mix and match in any way that you want. You might have one relay that's as well a relay for a phishing campaign and for Cobalt Strike that calls back to the same server, and maybe for a hardware implant that you left at the client. So you can use one relay for multiple components. Or you go entirely crazy and have multiple command and control servers for different reasons, and they can either connect to their own relays or the same relay. So there's a lot of flexibility in how you want to deploy your infrastructure, and we support you in that. So maybe before I get into the demo, are there any questions already that you might want to have answered? Okay. Oh, sure. Go ahead. We decided to open source it because we do use a lot of tools from the rest of the security community. And we feel like this tool is now mature enough that it's actually really useful in practical use. And there is not too much rocket science in there that's very Secura specific, and other people might use it. So we want to give a little bit back to the community. That's the reason. Yeah, sure.
You told that the tool helps in deployment of the, or actually configuring of the infrastructure.
Yes.
Would it also be possible to use it to, on the road, adjust the infrastructure, like when you're actually performing the red teaming?
Yes, that's definitely the case. So we do support initial deployment, and we do support adding additional components during the assessment. And also, if you want to reconfigure something, you can also do that with the tool.
Cool.
However, that's a bit of the more advanced configuration. I'm not going to get into that today. Maybe if you have some time left. But in the next few weeks, we're going to release a few blog posts, and one of them will get into that as well. Thanks.
Hi, thank you very much. Just a quick question. Why OpenVPN? What was the reason for choosing the product? Why not anything else?
Pretty much historic reasons, like that is what we have been using, and it works flawlessly so far. I know WireGuard and so on is fancier. We are looking into it for the future, but at the moment we didn't spend the time on that. But yeah, never break a functioning system, right? So, so for the demo that we're going to deploy, we're going to have two backend systems. One is an OSINT system, and one is a command and control system. The OSINT system will have an always-on VPN connection to a relay in order to perform all your OSINT investigation on here, and the client will not be able to see where it's coming from because everything is relayed via the OSINT relay. On the C2 machine, we're going to have a Cobalt Strike Docker container that is going via malware relay to the outside. We're going to have a Dropbox backend that's for hardware implants that you might be creating. That's going via the same malware relay. And we're going to have a phishing campaign for a help desk that's going via the phishing relay, and also some web catcher that's just arbitrarily catching callbacks. That's also going towards that phishing relay. So this is going to be 5 servers that we're going to deploy, and it should take about 10 minutes, I guess. And the inventory creation is going to take about 10 minutes, and then the tool will be able to deploy this entire infrastructure as shown here, just from the deployment that we have been doing. Let's see. But we're going to not only do the infrastructure deployment, but I'm going to also show you the first steps that you need to do when you clone the repository. So there's a number of, if you clone the repository that is on GitHub as of this morning, you will get the link later as well. There's basically 4 steps that correspond to the first steps that I've been showing you earlier. And the first thing that you do is you're going to run the step 0, first time setup. And this will basically install all the packages that you need in order to run the software. And it will give you some tips on what the following steps should be. I already had everything installed, so it's really quick. It doesn't work so well. So basically, and there's also in the README, by the way, after you've done the initial tool install, there's 2 things that you need to do. One, The globals.yaml file is a file where you have your basic configuration for your team, for your company, that's being used as the basis for all the future deployments. You need to edit it via Ansible vault edit globals. Default password is Ansible, but that's bad. You don't want that. So that's why for step 2, you might want to set a more sensible password on your internal configuration with your SSH keys and so on. But yeah, we're going to do what it says here. So we Ansible vault edit globals. The perfect password Ansible. Is this readable in the back or not? Yeah, great. Okay, so there's a lot of comments in here that will help you to figure out what you actually need to enter. Also in our blog post, we will get a bit more into it if you need a little bit more guidance. So first off is in the case of OPSEC, you only want your company, your team to be able to connect to the infrastructure. You don't want the rest of the internet to have SSH access to your infrastructure. So the first part here is configuring what net blocks and IP addresses, etc., can actually connect on the admin access to your red teaming infrastructure. Let's do something silly for the demo deployment. So you can either enter a net block or you can enter specific IP addresses. Next off, the relays will have an open VPN port exposed in order to make sure that the Dockers on the backend can actually communicate to the relays. But you also don't want to have this open to the rest of the internet because, yeah, the less you expose, the better. So that's why you need to enter here the command and control space where your C2 servers are, and only those servers will be able to connect to the relays via OpenVPN. And you can enter multiple spaces here as well. So that's the IP space configuration for the OPSEC part. Next off, here you enter the name of the Ansible deployment user. Pretty straightforward. And the next off is the default configuration for red teaming campaigns. So if you deploy a phishing campaign, people might actually return emails towards your phish. So in here you have a default email address that you're going to configure where emails will be forwarded to. You can still change this for every future configuration that you do, but you might have some generic catch-all for a red teaming phish that you have inside of your company. You have a toolkit directory where everything is installed on the C2. If you prefer a different name, you can change it here. And for all the relays, you're going to request Let's Encrypt certificates. You might not want to have your corporate email address in order to request them. So you can put a third bot email address in here in order to make sure that you can retrieve all the certificates. Next off, this information that you need from your team, because this is going to be used in order to configure users that can actually connect to your infrastructure. So, for example, we have first user is Ben, that's me. That's my username, let's do not me. You can create password hashes. Here's an example how you can create it. Just going to put some random data in here. And you need your public SSH key from all your team members. And pretty much if you configure this, you can use it during the later development to say, hey, this infrastructure person, Ben, needs to have access. And for deployment's sake, let's do a second one. Let's do Daniel. And this is also why you want to have a more sensible password than Ansible on here, because there's password hashes in there and public SSH keys. Not the worst if it leaks out, but passwords are important. And the rest of the configuration is just basic configuration that you probably don't want to change. But if you have specific use cases like different locales, etc., here's the place where you can do it. So that's it. Now you can put a different password on here. I'm not going to do it now because typing is hard during demos. But now you're good to go in order to create actual deployments for your red teaming campaign. So if we see again, now we have step 1, create configuration. First off, we're going to create a directory. Let's do hack in the box red wizard. Going to create a directory. It's using the globals.yaml that you've just been configuring. And here's something nice. If you have different teams or different requirements on the configurations that you have, you can create multiple of those global templates, and there's a flag for this deployment in order to choose your basic configuration for the future deployments. The password, everything that you see like installation default is Ansible. You can just press enter if you want to have the what's called the default value. But apparently I made a mistake here. Delete this for now. You should think after so many deployments I would be able to do this at once without errors. Yeah, indeed. Oops. As I said, typing is hard during a live demo. Yes, that was my mistake. So, and here it's going to, by the way, is it still readable on the bottom there in the back or not? Yeah, great. So, all the default values that you see here are the default values that you configured in your globals.yaml file. So you can just press enter in most of the cases where you have a default deployment, but you can also change them if you want to have something different for the specific campaign. For example, here the default name is a development. I'm going to call it red wizard. And the username for the Ansible user, in this case again, Ubu. And here you see the users that I configured. You can either pick one, for example, Ben, or you can add a comma separate list, or you can just say all users, and then all users will be deployed for this. And here you see again the basic configuration from the stuff that's going to be deployed. Should be what you wanted. If not, you can set any different values in here, or just continue. And here it's going to ask you for a few secrets. New Ansible vault password. So this is not the vault that you've just been created, but this is the vault for the red teaming campaign that you're going to create. Because, for example, your Cobalt Strike license key for deployment is going to be in there, the sudo key for the deployment and so on. So that might be specific for that specific assessment, and you might not want to share that to everybody within the team. So you might want to put a new password on here. Also password. This should be the password that the Ansible user can actually use to sudo on the system. Default password for GoFish. Cobalt Strike if you have it. And the Cobalt Strike license key. If you actually want to deploy Cobalt Strike, you need to enter license key, otherwise it won't work. And now it created two configuration files. So first off, the vault with the new password that we had. We can say Ansible vault view. Do it again. So this is really easy. These are the passwords and license keys that you just entered. Those are a bit better protected. But the other thing is the when I pressed restarted it, I did the wrong directory, but that's fine. I accidentally called it Y now because I want to press yes instead of red wizard. Again, the demo effect, but that's fine. And here's the configuration that has been created. So this is a derivative of your globals configuration with all the additional information that you put in there during the deployment script. So for example, here the code name was changed to red wizard. The users that you have selected are in here, etc. And this includes all the comments that you need in order to make manual changes to your deployment. Maybe our standard deployment script doesn't yet support something that you might want, or you might want to do some additional manual changes later. You should have all the information here to do some manual adjustment as well. Again, in line with everything should be self-documenting for this code. Okay. So your global configuration for your company or team is done. You have your generic configuration for the upcoming assessment. Now we're going to create the actual inventory. And that's pretty much, this is what we're going to create. For that we're going to use step 2, create inventory. And we need to provide the path to the configuration. Yeah. It doesn't translate too well to a zoomed in screen. But we have 2 components. One is we're going to add the servers. Those are the basic components, like where's your C2 machine located, where's your OSINT machine located, where are your relays located. And once you added them, some additional options for the phishing campaigns, etc., will become available. But in order to show what we're actually doing, I'm going to show you the deployment as it is progressing. I just need a second for that. Because there's a tool included in our deployment called the diagram. And that basically creates these diagrams from your infrastructure, so you don't need to create them yourself. It's part of the tool, so you can more easily share it with the rest of your team. And we're going to do that to Y. Yeah, we don't have a host file yet, but that's fine. So first off, we're going to add a backend. In this case, we're going to make this our C2, and we're going to have IP address 1.1.1.1. So now we added the server C2 on 1.1.1, and I can show you this by saving it. One second. Make this a bit bigger. Yes. Okay. Sorry, that took a little bit. So our humble beginnings, our backend C2 server on 1.1.1. Next, we're going to add also a OSINT machine, because we want to do OSINT for our campaign. Going to save this as well. So basic machines, pretty straightforward so far. Next, we're going to add some relay servers that we need to order to actually do our phishing campaigns, etc. So we say, going to add some, let's do relay malware. This one's located at 3.3.3.3. We're going to add another one, a relay for relay OSINT. And we're going to add a last one. And this one is going to be the phishing relay. Let's save this again. So, really easy. Those are now our servers. But pretty boring still, because there's nothing on them yet. Those are just basic servers that will get some hardening, but nothing interesting is happening yet. But that's something that we're going to fix by adding specific campaigns. So let's start out with the easiest. Let's add some OSINT campaign. You get a warning on this one because where the normal C2, as I showed over here, on your C2 machine you have a number of Dockers running and they each have their own OpenVPN connection to a relay. The OSINT machine is a little bit different because the entire server will have an always-on VPN to a relay, and the normal deployment would break on that. So you need your own server for that, and that's why you get this big warning message to make sure that you don't deploy it on a server where you plan to deploy other stuff as well. So we say we want to deploy it to our OSINT backend and to our OSINT relay. Let's call this campaign gather. And now we added it. Save. And now something more interesting should happen. And this is now what the tool will deploy. So basically, on the OSINT machine, there will be an always-on VPN towards the relay where there's an open VPN server running, and that should now be fine when you start deploying it. Next off, we always want to do some phishing because phishing is fun. We want to deploy this to our C2, and let's take the relay phish server. Let's call this the help desk campaign. Domain name. You actually need to own those domain names, of course, because otherwise it won't work. And one thing what we haven't released, what you might want to look into if you want to use this yourself, is that we have some automated website generator for our relays that takes something like, hey, we don't want to have a finance website that's AI generated on here, to make sure that if anybody ends up on the relay, they will get an actual website for the domain that you registered. We haven't released that part yet, so at the moment, the only functionality that we have is that somebody will be bounced to an address that you supply here. In this case, for example, hps-secura.com. And you need to configure some admin port for your GoPhish configuration, the 13337, for example. And now we get into the next important part. As I mentioned earlier, the relay decides whether it should show the website, or it should redirect somebody away, or it should make sure that somebody ends up on the actual phishing server that's behind it. So that's something we call the secret strings. That's just part of the URL. If anybody visits that specific URL and anything behind it, they will be forwarded to your backend. Otherwise, they will just end up on the relay. If you want to make it nice, you can do the manual version. If you're a bit lazy, we're going to use that later. You can do it randomized. So manual, we by default have 4. So we say the 4 strings never gonna give you up. Let's save this one. To create this again. So now we added 2 more components for you. We added a full-fledged mail server on the relay. It's running postfix, dovecot for the email handling. It has all the stuff installed for DKIM, DMARC. It has all the information for SPF and so on. I'm going to show you later how you get that information. You're going to have the reverse Nginx relay for everything GoPhish related. And on the C2, you will have 2 Docker containers. One is for GoPhish. Probably everybody who ever done phishing knows GoPhish. And there's also some manual fish where you can do fancy phishing with MUT. And it's nicely described in there how to do it. But if you want to do something that isn't supported by GoPhish, you can use that container as well. Next off, WebCatcher. A really easy component just to grab some random callbacks that are coming back. Going to deploy to our C2. Let that come back also via the phishing relay. Catch. This is on the same relay, so it needs to be the same domain. And we also need to forward it to somewhere. Oops. And here we just use randomized strings. I'm going to show you later how they look like. Same. So we added a new component, backend WebCatcher, also via the relay fish, and there's a new Nginx component behind it. So now Nginx, some secret strings will be redirected towards your GoPhish, and some secret strings will be redirected to your WebCatcher, depending on what you just configured. And finally, we have 2 more components. One is for physical implants. We're not yet releasing the code for Dropboxes that you can leave behind in your target infrastructure. We might do that in the near future. But for now, it will at least create a handler where anything with some OpenVPN certificates that are being created can connect back to. So if you have something like that already, it will be really easy to include it into Red Wizard as well. Let's do this one via the malware. This one is done as well. Sometimes the arrows are not as perfect, but usually that's fine. So Dropbox implant via the malware relay. And now the last thing, the Cobalt Strike campaign that we want to deploy, because to be fair, most red teams use Cobalt Strike. C2, malware relay. Let's call this the short term Cobalt Strike. Domain name, not malware.com. And let's redirect this one to Google. And let's do randomized strings here as well. And also we support out of the box DNS beacon functionality. You might need to configure some subdomain, and here you can choose the subdomain, for example, really not malware. By default, there's one malleable profile for Cobalt Strike in there, which is really, really crappy. You really don't want to use this one. But the template, what's in there is showing you how you can adapt your own malleable profiles to include the right variables that you need to deploy it in such a way that the listeners work automatically. So just pick your own malleable profiles, change some variables to what you see in here, and it's going to be explained. And then you have at least a sensible malleable profile, because if you use this one, you will definitely get detected. And the final component. So now we also have our Cobalt Strike Docker that's going to the malware relay, and pretty much our basic infrastructure is done. Now we can just kick off the deployment, and everything should be fine and dandy. If I'm not explaining what I'm doing, this will take about 10 minutes. And the subsequent deployment, which I'm not going to do live from here, but I'm going to show you a deployment, is taking between 20 minutes and about 40 minutes, depending on how many components that you install. So in about an hour, you can have a red teaming infrastructure that's good to go. And the nice thing is, when you're done, like, let's exit this one. And you mentioned earlier, can you configure it again? Yes, you can. You can just run the script again. It tells you, hey, something exists here already, but that's fine. We can continue. We can show our inventory. Everything is still in here. And we can just say, I'm going to add another phishing campaign to our C2 and to our OSINT relay. And then you can save it, and then you have your new component added, and you can deploy it again, and it should now be deployed as well. So there's two tools that help you communicate to your team what they can find where. One is this diagram function that I already showed you. But of course, they need to SSH to the system. So we also have our, let's see, create SSH config, and you supplied the path to the config directory. And you can just copy paste this to your team, and they have all the information that they need in order to connect to the servers. You already had their public keys, so they can just connect to it. And if you actually want to deploy it, we have our step 3, deploy infra. So before you deploy it, it asks you like, hey, have you checked all the requirements? Because if not, the deployment will fail. So if you run the stuff that it tells us, hey, okay, here's some stuff that are the basic requirements. You need to actually be able to SSH to all the systems. Have you tested it? And it does some sanity checking. For example, the C2 IP space that will be configured so that the systems can actually connect via OpenVPN. Apparently, your systems that I just entered are not in the C2 IP space, so it will fail. Also, do the domains actually point to the right server that you configured? All of the sanity checking. If you're good to go on those requirements, then you can actually go ahead with the deployment. In this case, it will fail because it's senseless information. But afterwards, it tells you like, hey, you might want to create the SSH config and the diagram. And the last thing is that, as I mentioned, you might need to do some DNS configuration on your system because, yeah, you want to send out phishing that needs to look legitimate, etc. So for that, you have the last part. It's called, what was it again? Oh wait, no, never mind. There's another deployment that I did. And wait, that's another thing that I wanted to show you. Sorry about that. So after all the stuff that you have been doing, you have your configuration.yaml. That's the one that I already showed. The host file, like the inventory that we have been created, again, is self-documenting. This has all the values in there that come out of the deployment script that I just showed you. It gives you all the information, all the variables if you want to manually tweak something. And there's a lot of stuff in here that you really don't want to configure yourself. That's why we have the scripts to do that for you. But the self-documenting stuff is quite nice for this. But also after deployment, it's going to create some exports auto-generated directory. And I'm going to show you that on one that's already deployed. Not this one. Let me quickly disconnect this before I show a wrong path. Sorry about that. Yes. Great. Instantly. So because it might be that your infrastructure crashes and you might lose some key material, etc. So we're going to export all the important key material out of the server. So if stuff crashes and you need to rebuild your servers, you have all the information stored in your installation directory. So we can do that without any issue. So we have all the client profiles for all the different VPN connections. We have some Dropbox keys. Oops. These are some client profiles that you can use for Dropboxes in order to connect back to your implant, to your Dropbox backend. You have all the Let's Encrypt certificates for the servers that you have been deploying. And you also have your DNS configs. And in here, it has all the information that you need to configure your DNS settings for your phishing domains to make sure that you have a phishing campaign that has all the DMARC, DKIM, etc. set. You don't have to think about it anymore. You can just copy paste this from here and everything should be good to go afterwards. So less thinking is always better. I have a few more a few more things that I want to show you on an actual deployed infrastructure. But because time is running a little bit short, I'm going to show you a few last slides before we spend some more time on it. And that's some closing thoughts. So where can you get it? It's been published in our GitHub repository from Secura as of today. It will be on the last slide as well. There will be some bugs in our public infrastructure at the moment. We have been testing it a lot. It seems to be working, but you know how it works with the first software release that's to public. You might encounter some stuff. Please send in an issue and we will fix it if it's reasonable. And these are the components that we currently release. So GoFish, Manual Fish, Cobalt Strike, OSINT, Web Catchers, and Dropbox. So all the basic components that you probably need for your red teaming operations. What did we not release, and that's what you might have to do yourself? So first off, all the specific red teaming secret sauce. So the malleable profiles that we use, OPSEC patches for GoFish, etc. Stuff to make sure that you aren't detected as a red team, but if we release it, we can't use it anymore. However, in one of the blog posts, we're going to show you how to actually configure your stuff in such a way that you can use your own stuff in a secure way. We're not going to tell you what you need to put in there, but we're going to tell you how to put it in there. We have some components for proprietary software that we cannot share publicly. And we have some hardenings that wouldn't work in the public release. So if you have specific requirements on how to harden your servers, please do a sanity check and so on. This should be quite fine how it is, but yeah, you are in control of your own software, so please check the hardening that we have done by default. the website generators for the relays is really nice to have, because if you can put on a financial website on your relay, you can, for example, let it be categorized as a financial website, and it might not get inspected by corporate proxy. So it's really nice if you have an actual website on there. And lastly, the server deployment, so putting the Ubuntu servers somewhere and putting the user on it, that's not released as well, but that's really easy to do if you have your Terraform or something else for your own deployment. Future public releases of stuff that we might, that we are using internally and that we might release after some reworking. One is integration with Red Elk. It's a cool tool by Outflank. There's a theme for your red teaming infrastructure that really helps to see like what is going on with my infrastructures. Is stuff being scanned from the outside, etc. So that might be nice to have. Some other components like man-in-the-middle phishing with Evil Genix or Modlichka. Support for non-standard relays if you want to do domain fronting and so on. And maybe even our hardware implants, but we're not entirely sure about it. But that's a bit of the roadmap of stuff that we might want to release. So before I can show you a few last things, I guess there are some questions. You go ahead.
Can you repeat the question, I guess?
Yeah, sure. Oh, there's a mic.
Look at that. You deploy new relays for phishing campaigns. How do you find the reachability to be? Like, do you often land in spam boxes despite the DKIM and stuff?
Phishing is getting harder, to be fair. Where about half a year, 3/4 of a year, it was fine to get a domain that's at least 2 weeks old, and then you can deploy your phishing. Would work fine. These days, it is much harder. If you really want to do some good phishing, you might want to have your domain be up months in advance. You might want to put an actual website on there. You want to get it categorized, and you might want to do some warm-up services, like actually sending out emails to some trusted addresses, replying to them, and so on. So the rest of the internet email infrastructure things, it might be an actual domain. If you just want to send out phishing to a client and it's not in a red teaming context, you of course can always get some allow listing, and then you can use this just the day before. But if you want to do some good phishing, you might need to put some work into it to actually age the domain. Good one though.
Would you also consider to add support for another command and control software, preferably some open source, that can be replaced by, that can replace Cobalt Strike?
Maybe. The thing is, we are using 2 other command and control type software besides Cobalt Strike, but we are not at liberty to release them in this case. However, actually configuring a different command and control framework besides Cobalt Strike doesn't cost too much time, to be fair. The Cobalt Strike role in here is relatively easy, and you can copy paste most of it. So if you have some very good suggestions, please add it as an issue. We can definitely take a look into it. And otherwise, in our blog post, you will find how to integrate your own software within those roles and to make sure that you can deploy it yourself as well.
Very nice talk. Thank you for open sourcing this. I'm in a situation where I'm using Red Wizard and I'm using Cobalt Strike. I spin up my relays and my targets, and I don't want to wait 20 minutes. How do I do that?
Sorry, could you repeat that? So you're spinning up, so you already want to do it while spinning it up, or?
I'm being detected.
Yeah.
And now I need to shift from a different IP space or get around, right? So the idea is that you spin up new infrastructure. So as a red teamer, you can use that and continue your operation, right?
Yes, indeed.
But the way I hear it right now, it takes like 10 or 20 minutes before your new infrastructure is online. Is this true?
Yes. That's correct. But
I do it beforehand?
Yeah. So what a common pattern for Cobalt Strike is, which works pretty well, is that you not only have one Cobalt Strike campaign, but you have at least 2 going on. One, for example, your short-term access, like the direct callback for your malware. And then you do some persistence where there's some long-term callback, maybe once a day, once a week, that's calling back on a different way. And then if your main way in, your short-term access is burned. You still have the long-term access that is calling back to your infrastructure. And that gives you some time to actually deploy some new infrastructure, or you deploy some more servers already up front if you know that you will get burned.
Okay, that's very clear. Yeah.
Cool.
Any other questions? Okay. Thank you, Ben.